Good morning, AP Stats. How are you? We are starting chapter 21 today. So if you are able to try and read the chapter ahead of time, that'll really help things move along. So when you have specific questions, you can ask me about it. So today is about more tests and intervals. A little bit of this is review. A lot of it is new. So as you need to, please pause and think about it. And I'm going to ask you a few questions to think about as we're moving along. So we are going to talk a little bit more about the null hypothesis and alternative and p-values today. So we know that with the null hypothesis, we are trying to say that something is true or not based on what's been happening overall. So the null hypothesis is a statement about the value of a parameter for the model. So that would be our p equals whatever the probability is, usually as a decimal, always as a decimal. Then we use that value to compute the probability that the observed sample statistic, what we did our sample of, might occur. So that is why we're using the null hypothesis. How do we choose it? Pretty much we're given the null hypothesis. That's what the norm is in the industry or whatever's been happening with the information previously. However, sometimes it will be 50-50. 0.5, that would be pretty much just the coin toss if you can't tell what the null hypothesis or the what's been expected over years has been. They talk about how we should think about the why of the situation. What are we trying to look for? And I have a few examples we'll be able to tell the difference between the null and the alternative. So the null must relate to the question at hand. It's context dependent. Fine. So reiterating, there's a temptation to state your claim as the hypothesis, null hypothesis, but we're not going to do that. You can't prove a null hypothesis is true. So we have to instead bring into the mix the alternative, and that's usually going to be what the question's asking. So is it higher or lower or not equal to what the null hypothesis has been? When you reject the null, you're left with what you want to show. So we're always talking in the alternative hypothesis context. Okay. So this is going to be part of the new things today. So let's keep this in mind. The p-values. So far, we've been finding a p-value. We've been talking about that it's big or small. But what is that p-value really telling us? So the p-value is a conditional property. Probability. It's the probability that the observed statistic given that the null hypothesis is true. So what we're doing is we're saying if the null hypothesis is true, what's the probability, what's the chance that we are going to observe what we saw in the sample? The p-value is not the probability that the null hypothesis is true. It's not the conditional probability that the null hypothesis is true given the data. It is the probability of us seeing the alternative happen if the null hypothesis were true. So let's go through how we would write this. So here's an example. Let me just go through it with you. This is from the book. So you probably read it already, and maybe you know I've seen this already, but the New England Journal of Medicine paper reported that 7-year risk of heart attack in diabetes patients taking the drug Avandia was increased from a baseline of 20.2 to an estimated risk of 28.9, and said the p-value was 0.03. And certainly right now we know that the p-value would be low. So the question is, how should the p-value be interpreted in this context? I'm also asking you to write the HO and the HA. So why don't you take a few moments, pause if you need to think about what the HO and HA would be. And then if you want, think about what the p-value would be in interpreted context. Okay, so I'm going to use my finger drawing. Let's see how this works. So the HO would be that the probability, P, would be, the proportion, would be 0.202. And the null hypothesis in this case, they're looking to see whether it in fact has increased the diabetes heart attack risk. So it's going to be P is greater than 0.289. Again, we as math students know that 0.289 is greater than 0.202, but is it statistically significant to this problem? Now, how should the p-value be interpreted in this context? What we're thinking about here is we're thinking about the whole idea that the p-value is saying that if the null hypothesis were true, what is the chance of seeing the alternative hypothesis, the sample that we did, happen? So the wording that I wrote out before this class was, if the null hypothesis is true of all possible samples of the same size, right, there's a 3% chance that we will see a 28.9 or more percent diabetes patients who would report a heart attack. Boom. So in this case, they gave us what the our samples proportion was, 28.9. So it's saying that if the null hypothesis is true of all samples of the same size, so that wording is always the same, comma, there's a 3% chance, or whatever your percentage is, that we will see, in this case, we're being given 28.9% or more diabetes patients reporting a heart attack. Okay, so let's look at another question. I have it on my next page, I think. I don't think I pulled it over here. Here it is. Okay, so here's the next question. So take a peek at this one. Have harsher penalties and ad campaigns increase seatbelt use among drivers and passengers? Observations of commuter traffic failed to find evidence of a significant change compared with 3 years ago. Explain what the study's p-value of 0.17 means in this context. I want to make sure that we're clear, just like when we were having issues with the confidence level versus confidence interval. In this case, we are actually being asked what the p-value means in this context. So that's when you're going to jump on this whole idea of, if the null hypothesis were true, given samples of the same size, comma, what are we going to write? Pause for a moment, think about what you're going to write, and I'll show you what I wrote down. Okay, so what I wrote down, similar, if the null hypothesis were true and no changes were made to seatbelt use, of all possible samples of the same size, there's a 17% chance of seeing seatbelt use at the observed level or larger. In this case, we did not see that, we did not see what the percentage is. So we have to say that this is the case. And now I'm looking at this here, that they compared with 3 years ago, find evidence that. Okay, so there we go. So let me just finish up. I'm going to stop here right now. I wanted to do a question, but I want to do this tomorrow. I'll start with alpha levels tomorrow. So what is our homework going to be? I put up Albert with, I think, 5 questions. Some of them are Z score related, and some of them are having to do with this p-value. Try your best to look at them. A lot of the wording is almost identical, greater than, less than, not equal to. So really look at the question and see whether you can figure it out based on what we've written on these slides. And let me know your thoughts on how this went. Have a great day, and I'll talk to you tomorrow.